Ladies and gentlemen, welcome again to Front Row Chaos. I am your host, Travis Smith, and today we're going to jump right into I think it's an interesting topic. I have long been a fan of space, and I've long been a fan of all that there is in our solar system, and so I thought it might be a good time to talk about that the light year represents. The light year is fascinating to me, and I've done some research on it, and so we're going to dive in to what the light year is and what our universe holds. So sit back and enjoy the show, because we're going to be talking about what is out in our galaxy and what the light year represents. So with that said, we're going to talk about what is the light year. A light year is a measurement of distance and not time, as the name might imply. A light year is the distance a beam of light travels in a single year, which equates to approximately 6 trillion miles a year. On the scale of the universe, measuring distance in miles or kilometers is cumbersome, obviously given the exceeding large number of miles in between planets and stars. It is much simpler for astronomers to measure the distance of stars from us in the term light year. For example, the nearest star to our sun is Proxima Centauri, which is 4.2 light years away. So it takes about 4 years for that light to reach us. So what's super fascinating to me is when you go outside tonight and you look up at the stars, what you're seeing is the past. That light that you're seeing is billions of years old by the time it reaches our eyes. So the speed of light is the consistent throughout the universe. In a vacuum, light travels, like we said, about 6 trillion miles a year. So that to me is beyond fascinating. To travel that far, it's mind blowing. So let's just look at this. Measuring miles, like we said, or kilometers is useless when you get out into the solar system. So starting in our cosmic neighborhood, the closest star forming region to us is the Orion Nebula, which is, get this, 1,300 light years away. Now, 1,300 light years away times 6 trillion miles by 1,300, and there's your distance, roughly. The center of our galaxy is about 27,000 light years away. Okay? The nearest spiral galaxy to ours, the Andromeda Galaxy, is about 2.5 million light years away. Some of the most distant galaxies we can see are billions of light years from us. Now remember, we're talking about billions of miles, billions and billions, trillions to get to these galaxies. So, measuring light years, how far back in time they are viewing. Because light takes time to travel to our eyes. Everything we view in the night sky, like I said, has already happened. In other words, when you observe something 1 light year away, you see it as it appeared exactly 1 year ago. We see the Andromeda Galaxy as it appeared 2.5 million years ago. The most distant objects we can see in the cosmic microwave background is also our oldest view of the universe, occurring just after the Big Bang, some 13.8 billion years ago. Now, astronomers also use what's called parsecs, which is alternative to the light year. Short for parallax second, a parsec comes from the use of the triangulation to determine the distance of stars. To be more specific, it is the distance to a star whose apparent position shifts by 1 arc second. Now, I am not an astronomer. I don't have a clue what they're talking about, but they have a way of measuring light years differently, And I think a parsec is around 3 something light years to 1 parsec. So it kind of narrows down how far things are away, but when you're using the parsec system, you have things that are that far away, and you're wondering, yeah, you look out there and you say, okay, there's the Milky Way. Well, the Milky Way has billions, if not trillions, of stars in its galaxy by itself. And a star is just like our sun. So are we really the only ones out there when we have billions and trillions of these stars like our sun floating around in the universe? In my opinion, no. Time will tell, right? What are we going to say? And what's funny to me is I just heard NASA the other day has not been getting the response from the aliens that they wanted to. Okay, we have been putting out radio transmissions, TV signals out into deep space since the 70s, maybe earlier. Okay, trying to get a response from whoever's out there. So we haven't been getting much of a response from them. So what did NASA decide to do? They decided to send nude pictures out there, hoping to get a response. So I don't know if that's going to work, because I'm not quite sure a nude picture of a male or female would do much to an alien if they're out there. But if it does, great. But that's their next move, or that is their move. They've done it, and they've put out nude pictures and shot them out into deep space. And hopefully somebody will see that and say, well, I guess we need to contact Earth because I like what I'm seeing. But I doubt it. But that's their deal. Like I said, light years are a common metric in astronomy. But what are they and how long are they? A better way to phrase that question would actually be, how far are they? Light years are a measurement of distance. And again, not time, just distance. The time light would travel over the course of a year, which is again about 6 trillion miles. There are about 8,766 hours per year. So the light would travel, again, roughly 5.9 trillion, or let's just say 6 for ease, a year. But how far is that really? How long would it take you to say to do a road trip equivalent to 1 light year? Well, let's see. The longest highway in America is U.S. Route 20, which is about 3,365 miles in length. Let's say you drive that, and you drive about 8 hours per day at an average speed of, let's say, 65 miles an hour. At that rate, you will make it from Massachusetts to Oregon in about 6.5 days. Going at that same rate, it's going to take you roughly 11.3 billion days to make a journey equivalent to 1 light year. The average American human life is 78 years on this earth, which translates into about 28,740 days. So you would have to live about 400,000 times longer than the average American to get there. So it's far, right? So another way to think of this, you're going to need a long-term help to do this road trip. So let's say you start having kids. The average age for an American woman to have their first child is 26 years old. So if you're having kids every 26 years, your great-great-great-great-great-grandchild will finally get there about 1.2 million generations later. If you're having trouble wrapping your head around this, you're not alone. Because a light year is a staggering number, if you think about it. Humans in general struggle to conceptualize very large numbers. For example, try to imagine how big of a room you would need to comfortably seat 10 people. Now do the same with 100 people, now with 1,000, and so on, right? After a certain amount, it becomes harder and harder to visualize what 100,000 people in a room versus a million people in a room. But the problem with thinking about space and distance between things in space is that space is really, really big. The light year was first used as a unit of measurement by the astronomer Frederick Bessel in 1838. Though he didn't call it a light year at the time, he was trying to use the distance light travels in a year to demonstrate the distance between the Earth and another star. 61 Cygni is the star. Now, for a second, let's go back to that light year road trip. Once you got that far, you would pretty much be nothing, right? You'd pass by Pluto, which is the farthest planet from us that we know about, correct? At about 8 million days into your trip. But that part of your journey would only be about 0.07% of the whole trip. Our nearest celestial neighbor, which is Proxima Centauri, is 4 light years away. They use the distance out there is beyond comprehension. I really don't think people, I didn't until I started to think about, how far a light year is. So basically all of your light year, you've heard this star is this many light years away, this star is this many light years away, this planet. How far, you start to think about that and you go, well, how can we travel faster than light? Because it seems to me we're going to have to figure that out, because we've all watched Star Wars and Battlestar Galactica and Star Trek and all these shows. And when they hit that warp speed or that hyperspeed or whatever you want to call it, when they're there real quick, right? We have to figure out a way to travel faster than light to get there before we pass away. I mean, it's not even, well, when you think about this, we have the Mars rover on Mars. Well, when we send a signal to that rover to do X, Y, or Z, it takes 20 plus minutes for the signal to get there, and it's traveling at the speed of light. We have to think much faster than the speed of light if we're going to really explore this universe. We've got to figure out a way to get there and to know that we can get there before it's too late, because I don't see any other way that we could do it if we don't figure out that kind of technology for us to either wormhole ourselves there quickly or to figure out a way to beat the speed of light, because it's not going to be beneficial for us if we have to just go by the speed of light. Okay, now let's think about this. There's another fascinating side to the light year. Since light moves at a finite speed, everything you see, like we talked about earlier, is outdated. Your view of the world is actually an image of what things look like at the instant their light began traveling toward you. If you were staring across a room, the lag in just billionths of a second utterly is imperceptible, right? You don't even know that. But look at the moon, and you see it as it was about a second and a half ago. Watch a sunset, and you're seeing the sun as it was 8.3 minutes ago. The effect is far, far more pronounced for the stars. They're light years away. So when you look at them, you're looking at them in the past. Sirius, the brightest star in the sky, lies 8.6 light years from Earth, which means the light you're seeing left 8.6 years ago. Put it another way, we always see Sirius as it was 8.6 years ago. Deneb, D-E-N-E-B, a prominent summer star in the constellation Cygnus, is about 25,000 light years away. Its twinkling glow was already en route to us while Aristotle was alive. And remember, other galaxies are even more distant. Powerful telescopes like the Hubble can detect galaxies whose light years have been traveling our way for billions of years. Thus, those images show us galaxies as they were billions of years ago, in some cases from a time before Earth came to be. In short, a light year describes distance only, but the light itself provides a sort of time machine, allowing us to observe the cosmos as it was a long time ago. How do we know the speed of light? Well, this is interesting because the crucial insight came from Ole Romer, a 17th century Danish astronomer. During the 1660s, he was studying one of Jupiter's moons when he noticed something odd. When Jupiter and Earth were at their greatest distance from one another, the moon would slip into Jupiter's shadow a few minutes later than astronomers predicted. When the two planets were closest together, the event seemed to occur only a few minutes earlier. Romer realized that the delay had nothing to do with it. Rather, it was an illusion caused by the time it takes for the light to span the extra distance when Earth and Jupiter are on opposite sides of the sun. His calculation shows that the speed of light travels at 131,000 miles a second, a remarkably good estimate, considering that he was doing this work 60 years after the invention of the telescope. The concept of light speed as a measurement of distance already happened by the end of the 17th century, following the discovery of the finiteness of light speed by Romer, says Frederick. People latched on to the idea so quickly that it's impossible to credit any individual with certainty. So a lot of people are out there and they figured this out, which way beyond my comprehension how they figured it out, but good for them. And at first, these ideas were necessarily vague because scientists had only a rough idea of how far away the stars are. The breakthrough moment came in 1838 when German astronomer Friedrich Bessel measured the exact distance to the star 61 Cygni in describing the huge number he got. Bessel wrote that light years employs 10.3 years to traverse the distance. That's the closest thing to a specific moment when the specific concept of the light year was born. Within a couple of decades, the light year was commonplace in popular science writing. They considered the light year insufficiently scientific, since it cannot be measured directly. Bessel reckoned that the distance to the 61 Cygni by observing its parallax, again, this is all above my head, the apparent back and forth motion in the sky caused by the Earth's motion around the sun. Parallax is still one of astronomers' most powerful tools for measuring distance. The European Space Agency spent 650 million euros, or 750 million bucks, on the Gaia Space Telescope, which is currently using parallax to measure the distance to more than 1 billion stars across our galaxy. So beyond the Milky Way, our parallaxes are too small even for the Gaia to detect. Astronomers calculate distances by observing certain types of variables, stars, or brilliant supernova explosions. Those approaches still rely on the parallax measurements and their point of reference. Because their work is so deeply rooted in this parallax, astronomers commonly use a second distance unit called the parsec. A parsec is that arc second. 1 parsec equals 3.26 light years. Sometimes a parsec is more scientific relevant, but researchers often switch between the terms for no obvious reason except style. Unfortunately, the sect and parsec sounds like a unit of time, leading to more confusion. In the 1977 movie Star Wars: A New Hope, Han Solo brags that he made the Kessel Run in less than 12 parsecs. Star Wars fans have tied themselves in knots trying to explain away that obvious goof. Better to stick with the light year. It's all the astronomer you need, and let's dabble in time travel as well. So parsec, very interesting. We have the parsec, we have the light year. Either way, I just want you to think about for a second how small we are in this world, and not just in our own world, but in the universe. It is almost, in my opinion, I'm not saying for sure there's life out there, but man, I tell you, just by the sheer numbers that are out there of planets and solar systems and stars, it's almost impossible to think that we are the only ones around. It's hard for me to even grasp that. So if you think about our nearest star, okay, the nearest star that we have to us is Alpha Centauri, and it's 4.3 light years away. 4.2 years, 4.3 from Earth is a distance that would take about 6,300 years to travel. We'll never get there if we don't figure out a way to get there. If we don't figure out a way to beat light and be able to get there in a measurable amount of time, then it'll never happen. And that is the biggest hurdle that we face. We have all of this great technology, but it's not enough to get us to where we need to go if we want to really explore this universe. We've got to figure out a way to get, if you think about what's out there, I think it's imperative that we get there and try to figure out what it is that is out there and how we even come there, how we can make contact with them and how we can figure out if there is anything out there, where does it lead us to? What kind of, advancements would it give us? Where would we go with the technology that we have? I have to think about where we're at in this world, how small we are, where we need to be in years to come. It floors me to this day that we got on the moon in the 60s and we haven't been back. I just, for some reason, that really, I don't know if you've seen the new SpaceX movie. It's called Elon, Return to Space. I watched it the other night on Netflix. It is really good. Elon Musk, I am a super fan of. Several of his things that he's done. And one, if you look at it, the space program that he has brought back to life, because NASA was not going to do it. And he stepped in. It's a fascinating movie about how SpaceX got to where it is. If you're interested in that, if you want to take a look at that, it's phenomenal. When we used to launch rockets before, right? We would launch them and there's like 2 or 3 stages, right? And all those pieces fall off. And when they come back to Earth, they just burn up. Okay, they're wasted. Millions and billions of dollars are wasted. So his biggest thing was, how am I going to make space flight cheaper? Because we can't be burning all these stages and just letting them go to waste. So what he did, if you don't know, is he developed a base to the rocket. So the rocket has a base like normal, right? And then on the top is where the little astronauts sit in their little capsule. So when this thing launches, it goes up till it's almost in space, okay? And then the capsule with the astronauts shoot off, and it goes on its way. It has another rocket underneath it. So it takes off, it gets into orbit. The bottom piece, the rocket that got him out of this atmosphere, comes back. And before it hits the ground, it has 4 little, like landing gear type wings that fold down. And right before it's going to come to the ground, the rocket fires again and sets that thing down absolutely right on the X or whatever target it's on. Now, he's done this on a platform that they've launched from on land. He has landed these rockets on barges out in the ocean, these bottom rockets that got the astronauts into orbit and then came back down, landed, took space flight to an absolute new level that we've never seen before. It has changed everything because it dropped the cost to like $4,000 instead of $300 or $400 or $1 million to do that. It was the single biggest breakthrough that NASA could have ever hoped for, and they got it done in the private sector. And it's phenomenal. You watch these videos when you're watching this movie, and it you cannot believe that we have that, but it wasn't easy. If you watch the movie, it took him 3 times, 3 failures in a row. And instead of giving up, Elon went another time, and that 4th time, they got the capsule into space, into orbit. The rocket came back. The bottom piece came right back, landed on the barge as it's supposed to. And I mean, when it lands, ladies and gentlemen, it lands straight up, just like it launched. So the mathematical geniuses that work for SpaceX, I cannot say enough about. To make that possible, where that thing comes back and vertically sits right on the launch pad, just like it took off, will blow your mind. And he didn't give up. 3 failures in a row. Most people would have scrapped it. I get all you are probably going to say, well, he's got enough money to do that. But think about this. When he started this venture, it was back in the early, and I mean like 2002. He told his team he had like $100 million to get a rocket into orbit, and they thought they could do it. And they didn't do it in the 3 times. And then he called them in. He called them into a conference center, and the one head guy from Germany, he said, I thought for sure we were all fired. And he told them, no, I need you to build another rocket as fast as you can, and I want to get it in orbit. And they went to work again to try to figure out what they had messed up on. Well, anyway, ladies and gentlemen, they finally got it into orbit on that 4th try, not with astronauts, mind you. These were all done without people. The next day, NASA called with $1.5 billion contract because he did that. Since that 4th time, and now he's launched a ton of satellites, you probably know. In fact, one night, ladies and gentlemen, I am out in the front yard. I am taking the trash out. My wife happens to come outside, and it's dark, okay? And I look up, or she starts saying, hey, what's that? And she's looking up in the sky, and there is a line. I don't know if you've seen this, ladies and gentlemen, but it is freaky. It was a line of lights in a vertical line moving really fast across the where the stars are, it looked like, because it was up there in an orbit. And I, for a second, thought, here's our Independence Day. This is not normal. Those are not satellites. They were like if you looked at the sky, they were like within a couple of feet of each other. Obviously, they're not that from their closest, but from what we saw, it looked like it was a vertical line, and it stretched from, from 3/4 of the horizon to the other side in a line. I thought for sure we were going to get ready for an alien invasion, but that wasn't the case. It was Elon Musk's Starlink satellites that they had launched. And what they would do eventually is they would start to break off and get into their own orbit and not be together in a line like they were. It was freaky. And I never have seen anything like that. I wasn't paying attention to Elon's launching of these things, but they launched them. And what that's going to be is a internet service. I think it's available now, where it's supposed to be the state-of-the-art internet. No matter where you are on the planet, it will be high speed. So that was what we saw that night. It was called Starlink, if you want to look it up. It's an internet service that Elon Musk has invented. And so therefore, there will be no place on the planet that you can't get high-speed internet if you have Starlink. But back to Elon and the launching of these things. So finally, they went and they finally launched a capsule with astronauts that were guys that had already been up in space on the space shuttle. So they knew about this, the risk and everything involved. And what was really cool about Elon's rocket with the little capsule on top for the astronauts is they have built-in parachutes. If something goes wrong, the rocket blows up underneath them. it should disconnect the capsule, and the capsule will float back down, and the parachutes will deploy, and they'll land safely. People asked him in that show, well, what happens if the rocket blows up? How do you know they're going to be safe? Well, from what the physicists told him and what other scientists have said is it should be nothing more to the people in the capsule but a ball of flame that comes around the capsule, which is nothing new to the capsule, right? It's got to come back into orbit so it can handle that. And as long as it doesn't blow the capsule up with the rocket, it should separate and they should come back down. So we won't have what we had back in the 80s when we were, if you're old enough, was in school watching the Challenger go up and blow up. And that was, I'll never forget that day. I was watching it. I think I was in, I can't remember what grade, but back then when the space shuttle was going to launch, you had TVs in the teachers would bring into into your classroom, and we would watch it. And when that happened that day, it was dead silence in there because I think we all knew what had happened, but nobody wanted to say it. I'll never forget that. And of course, I'll never forget when I was older and the space shuttle returned and burned up on entry. There is so many things out there that can do damage to us when we're out of this world. And it's fascinating to me. And I hope you enjoyed talking about it today, or listening to it, I should say, because I think it's something that we take for granted. We don't look up enough. We don't look out at the night sky and wonder, and it just should be in awe of how we are here, and we have oxygen, and we have water. Well, most of the time we have water, and we have all the things we need right here on this rock. And it's fascinating to me, and I hope you again enjoyed listening to this. And again, you can find this podcast on any of the carriers out there, Apple, Spotify, Amazon Music. Please like it if you would, and hit me up on Facebook. And if you have a topic you'd like me to cover, I would be happy to do that, because I'm always looking for good content and stuff that hopefully you can find interesting. So thank you again for listening to Front Row Chaos. Be safe and have a great day.